Now we shall discuss about the stability of partially submerged body or floating bodies. This is most important in the case of ships or boats. This is the two-dimensional projection of a body where fluid is filled, let us say, up to this height. So, this is the liquid free surface and this body is partially submerged, means this portion is inside the liquid and remaining portion is outside the liquid, right. Now, in this figure, which is complete here, here also we have a projection. We have a G here, through G we have a weight acting downward and we have a buoyancy force acting through B of magnitude Fb. Now, when Fb and W are same, in that case this body will float under this condition. If W is more than Fb, then this body will sink. If W is less than Fb, then this body will go upward. Now, because of some external force produced due to the wind force or due to the wave force or due to some other reason, if it gets tilted, right. So, because of some external couple applied in a clockwise direction, this body gets tilted. In this case, what happens? The symmetricity of the displacement of the fluid is also different in comparison to first figure. In first figure, the same fluid is being displaced in the left hand side and right hand side of this symmetric line which can be drawn through BG. But in the right figure, if we draw a line passing through BG, the more fluid is being displaced on the right hand side of the body than the left hand side, right. Because of that, what happens, that buoyancy point also gets shifted in comparison to the B. So, in case of fully submerged body, the buoyancy point with reference to body does not change, but in case of floating body, buoyancy point with reference to body is also changed, because buoyancy is dependent on the displaced fluid, right. So, in this case displaced fluid is different in comparison to this figure, though its magnitude may remain same. So, that is why it is fluctuating under this condition where W and Fb are same, but buoyancy point gets shifted. So, let us say buoyancy point is shifted from B to B dash. So, now buoyancy force is acting through B dash, which is of value Fv, and G is remain fixed. G remain fixed because G is function of mass distribution in the ship. So, through G we have a weight acting downward and through B dash we have a weight buoyancy force acting upward. Now, these two forces acting through G and B dash, they are going to make a couple, and what is the direction of the couple? Direction of the couple is anti-clockwise. So, overturning couple was acting in a clockwise direction, and because of the shifting of V dash, we have a restoring couple acting in a anti-clockwise direction. So, wherever this overturning couple goes, because of this restoring couple, this floating body will regain its original position like this, and this condition is called stable equilibrium condition. So, in this case of the floating bodies, the stability is defined by some other parameter. Like in earlier case, for fully submerged body, to have a stable equilibrium, G must below the B, but in this case we have the buoyancy point which is below G. So, how do we define which parameter is important? So, we have to define another parameter. If we draw a perpendicular through B dash, it intersect the line drawn from BG at some point. That intersection point is known as meta center. Intersection point is known as a meta center, right, and height measured along the BG from G to M is called metacentric height, GM is called metacentric height, and GM is a important criteria to have stable equilibrium and unstable equilibrium, right. So GM is very important here, which is called metacentric height. So for stability of floating bodies, which thing is important? GM is important. In case of fully submerged body, which things are important? The position of G and B. But in this case, we have defined another parameter which is known as metacenter, and metacentric height is an important criteria to decide the stability of partially submerged body. So GM is equal to BM, this point from BM minus BG. So if we know the position of B and if we know position of G, we can find out the GM with the help of this figure. So for stability, if GM is greater than 0, means M is above the G, we have a stable equilibrium condition, because in this case we have a restoring couple formed which acts opposite to the overturning couple, and when GM is equal to 0, when both lie at the same point G and M, then we have a neutral equilibrium. Neutral equilibrium means no restoring couple is formed, because both forces are acting through same point, right. So it will remain in that tilted condition. When GM is less than 0, means M is below the G, in that case we have a unstable equilibrium. And what is unstable equilibrium? Even there is a slight tilt in the position of any floating body, it will keep tilting in that direction till it takes new equilibrium position, which is undesirable in our case. If we want to design any ship, then we must ensure that it is having sufficient stability condition for sufficient large force which we expect on a ship in a sea, right. Many times these ships are stable, but if we have a very large wind force or very large wave, then this ship may get tilted and it will not regain its original position till some new force is applied through external crane or other device. And for ship and submarine or boats, this metacentric height is very important when it is in floating condition. So we have to find out the metacenter very carefully, and for finding out the metacenter we have two methods. First method is analytical method and experimental method. So either we can find metacenter height GM experimentally or numerically, which is also known as analytically. Since this GM is very important, and we know that in case of ships the position of G also may change because of the distribution of the people may move from one location to another location, or movement of containers, from slight movement of the container or position of the containers, this G may get shifted. So we have to keep all factors in mind in designing the ship very carefully from its stability point of view. So GM is very important. So to find out GM analytically, we are going to develop a relationship, and at the same time whatever we are going to discuss analytically, it has to be verified through some experiments, because whenever we do experiment, then whatever we can see we can believe, but whenever we are doing something numerically, in numerically we are assuming that G remain constant, but in actual practice this G does not remain constant, and whatever result we get we can't be satisfied 100%, but the beauty of analytical analysis is that it gives the result within few seconds for any kind of input with the help of softwares or with the help of calculators. So analytical results gives you the value very easily. Whenever we want to conduct the experiment, it is difficult to construct experimental setup and conduct, but whatever result we get, we can believe that these are having sufficient accuracy.